All right, so today we are going to be talking about algebraic proofs. Algebraic proofs are just essentially a way to justify what we do mathematically. It's a system of giving proof to show that something is true. So 2 plus 2 equals 4, we assume is correct, but a proof would be 2 plus 2 equals 4 because the addition property, or something like that. That's a very simplified version of it. And how we're going to do this is we're going to write formal two-column proofs. So what a formal proof is, first of all, it's a chronological list of what's happening and why it's happening. And then the two-column proof is just a way of organizing it all. So the two-column proof, if you're standing up, you're going to want to sit down for this. It has 2 columns. I know, mind-blowing. So when we write two-column proofs, we write them kind of like a T-chart almost, and we have our statements or our math on this left side. So like our 2 plus 2, what kind of 2 was that? 2 plus 2 equals 4. Y. And this would be our y side. Addition property. Now in the problems we'll do, there will be more steps, but we label these across the board 1, 2, 3, so on, so forth. We're listing all the steps we take chronologically. So essentially, the way you solve a math problem, you could just solve it on this left-hand side in as many steps as it needs, and then at the end, you're going to give your justification of why these are happening using properties and rules and such. Okay? Properties, yay! There's 9 of them here. I'm not going to go through each of them. You have encountered all of these before. You might not have named them as they're named here. I would copy these into your notes or print off this slide. I'm going to keep moving for sake of time in the video, but I would pause the video at this point and write down all of these or make a copy of the slides presentation from the 2.6 folder. Okay, so our first proof, we are supposed to solve 2 times 5 minus 3a minus 4 times a plus 7 equals 92. And so how we're going to solve this is we're going to write a 2-column proof. So real quick, we're going to make this 2-column proof. Alright, so our steps, or our algebraic steps, go on the left-hand side. Then on the right-hand side, we have our properties or our evidence. Alright, so whenever we start a proof, the first thing we write down is the problem itself. So I'm going to write down 2 times 5 minus 3a minus 4 times a plus 7 equals 92. And now my evidence for this, the first step, the evidence is always given. So my first statement is going to be given. 1, 1. All right. Now this is where the flexibility starts. So my second step, it could vary a lot depending on your steps and your evidence, because there's a lot of different ways to solve math problems. So in a class of 15 people, we might have 15 correct answers that none of them are identical, and that's totally fine. This flexibility it makes some people not feel good about proofs. It makes some people happy knowing that there's a ton of different ways you can do it. I like more rigid, straightforward, this is how it's done. But proofs are not in that manner. So first step for me, I want to distribute both the 2 and that -4 into the parentheses. So my second step is going to look 10 minus 6a minus 4a minus 28 equals 92. So we don't actually show our work. Our work is shown based on our justifications here. So what I did there was I used the distributive property to distribute the 2 and distribute the -4 into those parentheses. So back on this right-hand side, I'm going to say distributive. I'm going to spell distributive correctly. Maybe distributive property. Abbreviating is totally okay here also, just for the record. So first thing we do, the given. Second thing is going to be whatever step you take first. So me, I did the distributive property. We should probably do the distributive property here, just as a general rule. So next step, my next step, I want to combine like terms over on this left-hand side. So I want to combine the 10 and the -28, and then I want to combine the -6a and the -4a. So I'm going to end up with -10a minus 18 equals 92. Now, if we go back to our property sheet, when I am adding or subtracting, we have subtraction property of equality, we have all these different properties of equality, but if you're just adding or you're just subtracting, all you're going to say is subtraction property. I could also say addition property there, since I could have added those together. If I said 10 plus -6a plus -4a plus -28, then I could say the addition property. But it all just depends on how you want to do it. Then, let's see, where was I? Okay, now my next step, I'm going to get rid of that -18 because I want that over on the right hand side with the 92. So my next step on the left hand side is going to look like what it'll look like after I add that 18. So I'm going to add my 18 on both sides. Now you wouldn't typically show what I'm showing in the green, but I'm just trying to show it so you can see exactly what I'm doing. So I'm left with -10a equals 110. And if showing those steps that I'm showing in green helps you, you can show those. Just know that you wouldn't typically do that in a formal proof. Now my evidence for this, since I'm adding to both sides, is going to be the addition property. So since I added, it's the addition property. All right. Now we're left with -10a equals 110. Okay. So my next step that I'm going to take is I'm going to want to divide both sides by -10 to get that a by itself, which is going to leave me here with a equals -11. And now the step I did to find that was division. So I'm going to say it's the division property. So I'm left with a equals -11. So you could stop there, Or you could write a equals negative 11 again, and you could say it was the substitution property, since a equals negative 11 substitution property, since you can interchange the a and the negative 11, you can write substitution property. Because you could replace the a with negative 11, or you could replace the negative 11 with a. And those could go either way, and it would mean the same thing. All right? So this is an example of a two-column proof, or an algebraic proof. All right? So second type of problem. We're writing an algebraic proof again. So they want us to begin by stating what is given and what you want, or what are you words. So what you're trying to prove. So we're trying to prove that t equals d minus 5 based on our given statement of d equals 20t plus 5. All right. So we're going to set up a two-column proof again, which I didn't really give myself. Oh, no, I did. Okay. So we're given that, let's find a good color here, go with that. So we're given that d equals 20t plus 5. If the distance d an object travels is given by d equals 20t plus 5, the time t that object travels is given by t equals d minus 5 over 20. Write a two-column proof to verify this conjecture. So they gave us that distance equals 20t plus 5. So that's our given down here. What we're trying to prove is we're supposed to find out that it does, in fact, work as t equals d minus 5 divided by 20. So when we set up this proof, what we're going to end up with here, we have the d equals 20t plus 5. That's our given. So that's our first step here, is that given quantity. And that our final step is going to be what we're trying to prove here, this t equals d minus 5 plus 20. Okay? So, first things first, what we're going to do is we're going to try to solve this equation for t. Since t is what's left here on this left-hand side, and we also have a t up here, we're going to just solve this equation for t, and that should give us our final prove statement at the end that t, in fact, equals d minus 5 divided by 20. So my first step in order to get t by itself is I need to get rid of this plus 5. In order to get rid of this plus 5, I need to subtract 5 from both sides. So I'm going to write down d minus 5 equals 20t. Now, what did I do there? I subtracted from both sides. So, in order for me to subtract from both sides, I need to use the subtraction property of equality. So I'm subtracting. So I'm just going to say subtraction property. All right? Now, second step, I need to get that t by itself on this left-hand side. So I need to get t by itself, so I need to get rid of this 20 out front. So it's saying 20 times t. I need it to just say t. So the opposite of multiplication is division. So I'm going to divide both sides by 20. So I am left with d minus 5 over 20 equals t. Now, since I divided, my property is going to be the division property. Okay? Now, my step 3, this d minus 5 divided by 20 equals t, looks very similar to what I'm trying to prove, which is t equals d minus 5 equals 20. Now, the only difference here is the t is on the wrong side. So if I need to flip this equation, I can go back to my properties page and I can look and see that whenever I flip something, my property is this symmetric property of equality, which says if A equals B, then B equals A. So in order for me to flip this, I need to use that symmetric property of equality. So I'm going to say symmetric property of equality. All right, and that's it. That's my second proof. What? So the last one is a geometric proof. So it's a little different than an algebraic proof because it focuses more on geometry than algebra, but we follow the same steps. So if angle A is congruent to angle B and angle B equals 2 times angle C, and the measure of angle C is 45, then the measure of angle A equals 90 degrees. Write a 2-column proof to verify this conjecture. Okay. I got to find where I am. All right, cool. So, first things first, I got to write my given statement. So, angle A equals angle B equals 2 times the measure of angle C, and angle C equals 45. A lot of information given there. So then at the bottom I have this statement that I'm trying to prove, which is the measure of angle A equals 90 degrees. So that's my end goal. That's where I want to get to. So starting with my given, I know that the measure of angle A is congruent to the measure of angle B. So my first statement, I'm just going to say the measure of angle A equals the measure of angle B. Because if they're congruent, then they are the same. They equal each other. So that's going to be by the definition of congruent angles. So my second step is I'm going to say the measure of angle A equals 2 times the measure of angle C. And now what I was doing there is I substituted A into this measure of angle B equals 2m, 2 measure of angle C. Okay, now that property, if we go back to our property page real quick, that one is the transitive property of equality. So what that property says is if A equals B and B equals C, then A equals C. So if A and B are the same, then they both will equal C if one of them equals C. So let's just say, real quick example. So if A equals B and then B equals 5, well, by this transitive property of equality, if B equals 5, then A also equals 5, since A and B are equal to each other, okay? So, now we write our transitive property of equality. All right, so now I'm going to plug in, instead of measure of angle C, since they tell us the measure of angle C equals 45 in the given, I am going to say measure of angle A equals 2 times 45. So I'm substituting in that 45-degree value for the measure of angle C. So I'm going to say substitution. And then once I multiply that out, I have the measure of angle A equals 90 degrees. So now what the book wants you to say here is substitution as well, since you're substituting the values. Me personally, I would say the multiplication property. Multiplication property. Both are correct. You could also say the substitution property. Both of those are accepted. I mean, there's a lot of different ways you could say it. So really any of those are acceptable. So big picture, what I want you to get out of this is that proofs, when we're writing two-column proofs, you have your, let's go with green. So you have your statements, so like your math on the left side, and then you have your reasons or your evidence. So you have your, essentially on the left-hand side, you have your what, and then on the right-hand side, you have your why. So we've been doing this left-hand side here for the past 8 years of school. You've been solving math problems. What's new is this why, where you're justifying what you're doing using words. We usually justify it by showing our work. Now we're saying why we are doing those steps that we're doing in our work. Proofs, you love them or you hate them. If you have any questions, please let me know.